Okey-dokey. Yes, we definitely gonna get that. Okay, put phones away, put quizzes away. But I need to know where you guys are at, and I need to know, if you need some extra help, you can stay after class. If you missed a quiz and while I was gone and you want to stay after class and make it up, you can do that. I had a pretty serious medical emergency. I had 2 strokes 3 weeks ago today. And I luckily have been very fortunate that it didn't affect anything of my body or my brain. So I was very, very fortunate. And I had a little puppy rescue me that kept me alive, and she went and got me help. So it's sort of a good little, 2020 story or 48-hour story about my rescue dog. But I'm happy to be back, and hopefully everything's going to be fine. And I really apologize for not being here for those 4 classes. I have never been sick in this semester. I've been told that I'm not invincible, I guess. And so I'm back here with you, and hopefully we can get you back up on track. So I'm willing to help you if you're stuck, confused, didn't do the homework. You gotta hand it in to me this week. If you're missing any assignments, if you haven't done any, you got this week, by Wednesday to hand it in to me, and I'll forgive you. If you want to make up a quiz that you missed and didn't take, either quizzes, what was it? Is it 11, 12, 13, 14, 15? And I gave you 16 as a take-home. So any of those quizzes, you gotta make them up this week. Starting today, though, the next quizzes you got to do on your own. No more partner stuff. I felt bad that you had a new instructor, and so I told her to be a little lenient with you. And some of you, did real well, but I need to make sure that you know this material. A week from this Wednesday, not this Wednesday, but the following Wednesday, you have a 100-point exam that covers all of the material, basically, that I wasn't here for, or what I'm going to cover this week. Next Monday, we do the review, and then next Wednesday, you take a 100-point exam. So it's real, real important that you know how to do everything from day 11 through day 20. Okay? All right, today's lesson is my favorite lesson of the whole semester, so I had to come back for this one. And it's going to help you with everything that you had with Krista, because you need to know how to do Krista's material in order to do my material today. So I'm going to review a little bit with you. And so if you take out your notes for today, we're going to start. Now, today's lesson talks about solving these rational expressions. A rational expression is a fraction, but it doesn't look like the fraction that you had in 3rd grade that looks like that. Our rational expression has to have some variables in it. That makes it a rational expression. It's got some variables and numbers. All right, today and with Krista, she taught you how to add them, subtract them, multiply and divide. Do you agree? And then you had what's called complex division. That's the quiz for today. It's a division problem. You got a fraction on top and a fraction on bottom. She taught you 2 ways to solve that puppy. If you don't know, stay after class. If you're confused, and we'll go over it, and you can take your quiz if you want. So. But you got to learn all those ways of simplifying rational expressions. Now today we're going to solve, so stay with me, just watch. I color-coded a lot of stuff for you to help you understand it. Today's direction is going to say solve. It won't say add, it won't say subtract, it doesn't say multiply, it doesn't say divide, and it doesn't say simplify these complex, fractions like what's on your quiz for today. Look, this is what your problems look like with Krista. And your job with Krista is to find the LCD. Now, your quiz today, problem number 1 says, find the LCD of something like a 3x and a 6. And so if you look, I put the LCD as 6x. Do you agree? That's your common denominator, your least common denominator. And then what you had to do with Krista is this. You had to say, what's this first denominator need to make it a 6x? What is it missing? A 2. So Krista told you, oh, you got to multiply the top here by 2.
Oh, on that one, okay.
And what's this 6 missing to get a 6x? An x. So you needed to put an x next to the top. Now that's where this 2 plus 5x comes for your answer all over the LCD. That's what Krista taught you. Are the light bulbs going back on? Okay. Now today, this is my lesson. My lesson is going to say, now we're going to solve. And you're going to love today's lesson. Because what we're going to do is come up with the problem that we did the very first day of class. Looks like this in green. Do you see that? No fractions. You got to add something to both sides and you got to divide. You go, hallelujah, give me back to the first day of class. I'll get an A in the class. Now, how do we take this red box and make it look like the green box? That's what I have to teach you today. You get it? We want to change the red box with these nasty, icky fractions, rational expressions in it. We want to get rid of those guys. They're bad. So what do we have to do? Well, look. Step 1 is you have to factor all your denominators. I can't factor 3x anymore, a 6 and an x. Can't factor anything out of all 3 of those. So then I have to find the LCD. Exactly what you did with Krista. Look at your 3 denominators and you got to say, what number can go into all 3 of those denominators? And the answer is still 6x. Exactly what it was with Krista. So the reason why I love this lesson is because it's nothing different than when you add for the first couple steps. But now watch, this is the cool part about today. Once you get your LCD, we have to put what we call a restriction down there. Why do we have to put a restriction? Because we have variables in our denominator, and we have to make sure that that denominator doesn't have a value of 0. Why? Take your calculators out. Take 6 on your calculator and divide it by 0. What does the calculator say? Undefined. It doesn't say 0. It says, you're wacky, this is impossible. That's what undefined means. It means you can't have x being 0 because if x is 0, it's undefined. You can't divide something by nothing. Does that make sense to you? Okay? I can't sit there and say, I'm going to give you guys all nothing, and then what do you get? Well, you have nothing. All right. So what we have to do that's new today is take the LCD and put it equal to 0 and solve that problem. Now write that on your notes. You're going to take the LCD, put it equal to 0 and solve. Now I'm going to divide each side by 6 and I get x cannot be equal to 0. If x is 0, my calculator says undefined. Now, this is a new part. Besides putting the LCD down, you have to put what we call a restriction down. The restriction is gotten by taking the LCD, put it equal to 0, and solve, either in your head or on your paper, I don't care where. And then a restriction, you put a line through the equal sign and say, you gotta be careful, because if you get x is 0 for a solution, you gotta throw it away. It's a bad answer. All right, so that's the first new thing. Otherwise, factoring, factor all the denominator, finding the LCD is exactly what you did with Krista. This is new, and now the next part is new. Watch. We're going to take my LCD, watch, and write this in your notes. You're going to put the LCD right next to the first numerator, right next to the second numerator, and right next to the third numerator. That's different. When we added them together, we wanted both of these to now say 6x. I want my denominator to say 6x. I want to keep the denominator when you added them. But when we solve, we want those puppies out of here. Get away. I don't want you. I don't want any fractions in my problem. So now why did I put the 6x next to all three numerators? Because the 3x will cancel with the 6x, and I get a 2. So now I just multiply 2 times the old numerator. That's where this guy comes from. See that? That's where this guy came from. 2 times 1 is 2. And I no longer have a denominator. That's why I love this lesson. If you know how to find LCDs, you're going to end up with a math problem that has no denominators to it and a really easy problem that everybody's going to get an A on. Now I go to the next fraction here. The 6's cancel. What's left on the numerators? What do you see?
X5.
5 and an x. We put the 5 in front of the x. That's where that 5x comes from. I got rid of the denominators. I got rid of the big F word, no more fractions. So now I come over here and I say, oh, this x cancels with that x, multiply what's left, what do you get? What do you get? 12, that's where that guy comes from. Guess what? We're back to the first day of class. Yeah.
Why did you take the LCD and equal it to 0?
Because we have to determine what numbers cannot be solutions for this equation. And now that we have variables in our denominator, we have to be careful, because if I get a number that makes that denominator a 0, my calculator, as you saw, will say, undefined, you're wacky, you can't use that solution. I'll show you one in a minute. What do I have to do for the green problem? Do I have to teach anybody the green problem? Can everybody in the room do the green problem? This is a Math 92. This is a ICS math problem that they do way back when. You got to subtract your 2 from both sides if you forgot. You get 5x equals 10, divide each side by 5, x equals 2. Now you go up here and you check, is that a restriction? Did I say x cannot equal 2? No, I said x can't equal 0. So 2 is called a good solution. You're done.
Once.
You're done. Now, that's all I'm teaching for today's lesson. So now we're going to practice, and you have to practice with me. Then you're going to practice with your partner. Then you're going to practice on the board so I can see it. So everybody needs to ask questions if I lose you. All right, look up here. Watch. Every problem is a little different. This is one fraction problem. Do you see the fraction? It's called a rational expression. It's got something on top. It's got a variable on the bottom. This guy here is another term, but it's not a fraction, but I have to be careful. So a lot of you should put a 1 underneath it, just so you know that there's 2 terms on the left side. Okay? Now here's my other fraction, but it's on the other side of the equal sign. So there's three things that have to be multiplied by the LCD. Do you understand that? Three. This fraction needs an LCD, this needs an LCD, and this needs an LCD. So now I gotta come up with, what's my LCD?
This is still
Well,
A
the
minus
rules
6.
say, look at your denominators. Can you pull out a GCF? No.
No.
So what's my LCD?
A minus 6.
A minus what?
6.
6? That's what Krista taught you, before break. She taught you to look at your denominators, factor it if possible. If it's not factored as possible, I said, okay, go write LCD equals, and the first denominator here is an A minus 6. Now the second denominator is a 1, so I don't have to worry about that. What's the third denominator? A minus 6, same thing, I already wrote it, so I don't need another one. Now, okay, somebody help me, there we go. All right, so did you see how I wrote LCD equals A minus 6? I physically write that on the paper. Now what we have to do new is called a restriction. You gotta tell me, what are bad numbers? Bad numbers are numbers that will make my denominator say a 0. So you take your LCD, put it equal to 0, and now solve. A minus 6 equals 0. What does A equal?
6.
6. So in your LCD box, we now have to write what we call a restriction. Why? Because if I end up solving this problem and it should say A equals 6, I got to throw it out because my calculator will call it an error. It'll say you're wacky, you can't have A equals 6. So I have to do this piece now when I solve. You didn't have to do that piece when you were just adding, subtracting, or multiplying or dividing, because it wasn't equal to anything. My calculator won't say error, but it'll say error if I put in a wrong solution. All right, so now what do we have to do? Well, the next step is to take that LCD and get rid of all your fractions. So I need to write this in your notes, put an A minus 6 next to the first numerator, write it in. Take an A minus 6, put it next to that negative 5. Even though it doesn't have a denominator, to keep it balanced, what we talked about the first day of class, keep everything balanced. Everything has to be multiplied by whatever you're multiplying the first term by. And now I've got to take that A minus 6 and multiply it by the third term. If you pick the right LCD, guess what? We're back to the first day of class. So watch, the work I'm going to put on my paper, cross those puppies out. Hee-haw, no more fraction. What do I bring down?
2.
A 2. Bring down a 2. How hard is that? Now I go to the next one. Do I have any denominator to cancel out?
No.
No. So I have to bring down this negative 5 times the, negative 5 times the A minus 6. God, what are they doing here? Come on, board. Okay, negative, oh, there it goes. Anybody want to help me?
I think you have to click it
I did. That
no,
gives
with
me-
the pointer, yeah.
Oh, you're good. I love my techie people. Okay, go to the third fraction. A minus 6 cancels out. What do I bring down? 2 times the quantity of A minus 5. Now, look at this problem that's right here. That's the first day of class. and I called it Rainbow. Do you guys remember it? So we went from a very nasty, nasty problem to one that's like, oh my gosh, that's the old Rainbow from Math 92 from ICS. You've done this kind of problem below the line already. So you've got to distribute the -5, you got to distribute the 2, you got to combine your terms, and what do I get for a solution? Now, I didn't show you all the steps, but what do I get for a solution?
6.
6. So I go back up to my LCD box and I said, have I thrown out 6? Yes. So there is no solution to this problem. It's a made-up problem that can never mathematically be correct. So because I got A = 6, and that is my restriction, what I have to write down on my paper is empty set. You see why, Angel? If you get a solution that happens to be a restriction, you got to throw it out. And if there aren't any other solutions, you got to say empty set. God, this is awful. All right. Yeah.
So would you just write no solution?
Yeah, you write this, empty set. Okay, again, the rest of this lesson is practicing changing a hard problem to an easy problem. So let's look at problem number 1 here, and with your partner, you guys can be partners, and will you guys turn around and join him over here? Look, okay, everybody else is a partner. With your partner, I want you to just fill in LCD and what the restrictions are. Try it. If you have no clue, you say to your partner or your group, I don't know what she's talking about. I don't know. Talk about it.
I'm not sure because I was making this fraction again.
Turn around and ask.
You're adding the colors.
I appear to be doing the same thing as everyone else.
Okay, how much work does this guy take? Nothing. You don't have to factor your 2 denominators. Look, watch. I even highlighted it for you, which wasn't on your paper originally. Do you see the y + 5 in yellow? That can't be factored, nothing can be factored out. So that's just a binomial that's going to be part of my LCD. Krista covered this with you if you were just adding these 2 things together. You see the green blob? You look at the green blob, you see it? Nothing can be factored out of that. So I have 2 fractions in this black box. Do you see the 2 fractions? There's my fraction bar, here's my fraction bar. I have 2 fractions in there, and your job is to get rid of those denominators. You got to erase them, you got to take them away, but you got to do it mathematically. You can't just go, bam, get away, little yellow blob, get away, little green blob. So I have to go over, and I always put it to the side of the problem, what's my LCD? Well, what do I have? What do I have? I have a yellow blob, and I have a what? Green blob. So let's, oh, you know what's confusing it is I had 2 things up there. No. You guys, what's wrong with my board?
It thinks your finger is an eraser.
Oh, I love you techie people. Thank you. You see how I used my eyes, nothing else. I just used my eyes, and I took the yellow blob and I took the green blob and I called that my LCD. Because there's no GCF in either one, it's just y plus 5 and a 3y minus 2. Those are two binomials that are in my denominator. Now what I have to do different today is I have to put each of these equal to 0 and solve to get what we call restrictions. Those are bad answers. Now, you can either show the work by subtracting 5 from both sides, and you get y equals -5. Then over here, we have to add 2, divide by 3, first day of class, and you get y.
It's not you.
It's not me.
Oh, the scarf
I think
thing,
it's
not
this.
scarf footer.
Okay,
Clothing item.
so I get y cannot equal 2/3. You understand where those two numbers came from? Those are called bad solutions. If when you're all done down here, you end up with y equals -5 or y equals 2/3, you gotta throw it away. You gotta say it's a bad answer. Because if I get -5 and I put in -5 plus 5, what's my denominator gonna say? 0. And if I do 3 divided by 0, what's your calculator gonna say? Error. It's gonna say you can't divide by 0. So these are called restrictions. And you have to do that right underneath your LCD box because it's really easy to solve. And you don't have to show work if you don't want to, but if you have to, you can add your 2 and divide by 3 if you need to get your 2/3 and your -5. Now, once I'm done with that restriction, now I've got to take my LCD and multiply each fraction by the LCD. Do you see my yellow? And here's the green one, that's your LCD. And if you notice, these guys go away, right? Hallelujah, I got rid of my denominator. Go to the other side and what cancels out? Not the y plus 5 again, but the 3y minus 2. Now, whatever's remaining on the numerator has to be multiplied together. What we did the first day of class. 3 is remaining, and the 3y minus 2, the red. 3 is remaining, and the y plus 5. I'm back to day 1. Now I've got to distribute what we did the first day of class, rainbow. Get my variables all to one side. Divide by 6, reduce, I get 7 2s. That's the answer. That's what y has to be for the left side to equal the right side. You leave it as a fraction as long as it's reduced to lowest terms. If you said 21/6 on a test or a quiz, I'd take off a point because you need to know that 3 goes into both of those numbers. Okay, y is 7 2s, that's my final answer. Go check, is that one of my restrictions? No, so I'm done. Look at problem number 2. You see the green, the yellow side and you see the green side? Answer me. Okay? They cannot be called the GC, or they can't be called the LCD. Why? Because you haven't what? Factored. You have to be able to factor quickly. Either using X-Men. Some of you, I noticed, when you handed in your extra credit, did guess and check. That's fine. These are easy because the lead coefficient has a 1 in front of it. I can guess and check what that factoring is. But I want you to write this on your paper. You need to come up with x plus 1 and an x minus 2 by factoring. either using X-Men that I taught you before I got sick, or guess and check, or 4 terms. Some of you are using 4 terms. I don't know how you do that. I can't. My brain doesn't work that way. It's hard for me. But some of you do it by 4 terms. But you gotta come up with x plus 1 and x minus 2. Then you go to the other one and you gotta do an X-Men again, or you can guess and check, and you come up with x plus 1 and an x minus 5. Now let me give you a Barbier shortcut. I always factor whichever one is gonna be the easiest first. And I'm gonna take you to Las Vegas. In Las Vegas, I'm going to tell you that if you had this problem in Las Vegas and you went to the next table, they're going to repeat one of them. Which one did they repeat?
One.
X plus 1, right? See how that came back and bit you right in the rear end again? Right? So when they give you a trinomial and then another trinomial, chances are they're going to have a common binomial 2-termed expression. Now, look at my LCD. I write the x plus 1, the x minus 2. I always write the first one down in the LCD line. And then I say, what newbies are over here? X minus 5, right? This guy is the new one. I already have the x plus 1 written up there. I don't need a double. So now my LCD has 3 binomials. It means you need 3 restrictions. You have to put the x plus 1 equal to 0, the x minus 2 equal to 0, and the x minus 5 equal to 0 to get your restrictions of -1, write it down, a +2, and a +5. Those are called bad answers. If you get that as any of your solutions below this line here, then you're going to have to throw it out. It's called a bad answer. All right. So if you notice, I took my original problem, the x plus 4, and now I have this x plus 1 and an x minus 2. It's in factored form here. Now, I don't rewrite it like I did here. I'm lazy and I'm sloppy. I just write it right underneath the original fraction. But I want to show you what that black box would look like if you take your denominators and factor it. So it's just a visually easier thing for you to do, but you don't have to rewrite this whole step. But now we have to multiply each of those black boxes by the LCD, because guess what your goal is for all of today? Get rid of your denominators. We want a math problem below this line here that's taking me back to the first day of class. So now watch. The x plus 1s cancel out. Hee-haw. The x minus 2's cancel out. Hee-haw. What do I have left? X minus 5 times an x minus, or x plus 4. Now you go to the right side and you go, hey, I got to do the same thing on the right side. So now I look and I say, oh, I have an x plus 1s. Those cancel out. What else cancels out? X minus 5s cancel out. Hee-haw! I got rid of all those denominators. Denominators are bad. When you were in 3rd grade, they could have taught you how to get rid of fractions and not taught you fractions the way they did for the next 10 years of your life by doing what I'm doing now. All right, what do I have left? A 6 and an x minus 2. That's what I have. Now below this black line, do you see how I'm back to like the first day of class, second day of class? Now you got to multiply these two together. Do you remember how I taught you how to multiply two binomials together? Some of you use FOIL, first, outies, innies, and last. And some of you are gonna put a box down. Do you remember that? It's from exam 1. You did this on exam 1. If you passed exam 1, we're going back to exam 1. You have an x squared, a 4x, negative 5x, and a neg 20. And that's what you put on the left side. Has it registered in your brain yet that you gotta get every step of every day? Because in math, it comes back to bite you if you don't. You can't take shortcuts, you can't take easy steps. You can't just get an answer without knowing how to get the answer, because I'm gonna go back. When we get into logarithms, we're getting into a little trig in this class by the end of the semester in May. I'm getting you ready for your next 151 class or your 142 class. You gotta know how to do some trig with me. And you can't do the trig unless you know how to do what I'm teaching you right now. So if you're confused, if you're stuck, you haven't done the homework, you gotta pick it up and you gotta do it. Because if you don't do it, it's gonna bite you. And again, it's not gonna be a fun bite. You're not gonna be passing the class unless you understand all the steps. Okay, is that me? Oh, God. Okay. So what's my next step?
Equal it to 0.
Collect like terms on one side.
Yep. You gotta get the neg 6x over to this side. So now I have neg 7x. You gotta add 12 to the neg 20, I get negative 8. Now I've gotta factor the left side. You're going, are you kidding me? That's what we did on exam 1. Yeah. On exam 1, you did this. Do you remember that? I'm not teaching you anything new today except this piece. Isn't that weird? Restrictions are the only thing that I'm teaching you new today. Okay, once you get this factoring, and again, those of you that handed in your extra credit to me, and you showed me that, you know, when I give you this math problem right here, you can factor it to this step. If you don't show me a stick of work, I'm assuming you're doing guess and check. But on a quiz or an exam next week, when you get to this step, you better know how to factor it. And you can't take shortcuts, you gotta know how to factor it, either guess and check, or you're gonna do the X-Men over here and use your multiplication sheet. But you gotta work hard at it, you can't just sit there and go, I don't know how to do this, and then hope it comes in a nightmare or a dream. It's not gonna come. You gotta be able to factor. Once you get it to here, now how do we solve? Well, we've done that already, haven't we? Is it equal to 0? Say yes. Now you gotta put the x plus 1 equal to 0. You have to say the word or. That was the day before I got sick. You put the x minus 8 equal to 0, and now you solve. And notice I got one solution that says x equals neg 1. And I have one solution that says x equals 8. Well, these two solutions are based off of this problem, not my original one way up here. The original one up here has what we call restrictions, because those things are in the denominator, and you can't have your denominator equal to 0. So I go and check, neg 1 and 8, are any of those my restrictions up there? Yep. So in the answer blank, this is called an extraneous solution. You can't have the neg 1. So the only thing you put in your funky brackets for a solution set is an 8, not a neg 1. Put a neg 1 in there, I'm going to take off points because you're not checking the restriction. Okay, go to the next slide. With your partner, turn around if you're in a group of 3 or in a group of 2. I want you to tell me, what did I do from this step to this step? And just write it over here. What did I do? What the heck, what makes this line different than this line? What did I do to this line? What am I doing to this step? What am I doing to this step? What am I doing? Go through your group, with your group, and just write down, what did I do? Go. Turn around if you're not with your group. Work as a group of 3. If you don't know, tell your partner, I don't know, can you explain it to me? Somebody might be explaining it much better than I can explain it. What did I do? Don't do the work, just tell me, what did I do? Real short, use abbreviations, use short words. What did I do from step 1 to step 2? What did I do from 2 to 3? What did I do to 4? What did I do to 5? Below the line, what did I do to make that a nice problem? If you don't know, ask your partner why they have something written down there.
If you find the least common denominator, then multiply the fractions so that they're equal, right?
I think
Right.
you're growing.
What about the part where you're finding that's not equal?
When it says solve, real big solve, the first thing you always look at is, does it have any fractions to it? And if it does, you want to get rid of those suckers fast. You don't want to solve a rational equation. Rational equation means you got some denominators, means you got some variables in those denominators, and you got to get rid of those variables in the denominator. What did I do? To find the LCD, least common denominator, to get rid of those denominators, first thing you have to do is GCF. That's what we did the very, first and second day of class in here. I gave you 4x minus 4 and I said factor. Do you remember that? We did that the first day of class. You did that the first day of class in Math 92 if you were in 92, or ICS, they do that. So from this step to this step, that should be a piece of cake. But you gotta have a strategy. The strategy is you look for GCFs in your denominators. Once you get all the denominators, you can color code each of the factors. If I would have been here when you taught it, I would have always told you, write the first denominator down on your LCD step. So I would have put an x minus 1 down there. Now I look at the second denominator. Is there any newbies, any new colors? A 4. Numbers go in front of the binomial, so I put a 4 in front of my x minus 1. Now I go to the last denominator and I'll say, any new colors? Nope. So that's your LCD, 4 times the quantity of x minus 1. Now the next line, the book does it this way. And I've noticed some of you do that, where you put each side in big brackets, and then you multiply each side by the LCD. I do this method. Where I put my LCD next to all 3 fractions. Do you see the yellow blobs there? And when you put the LCD next to each fraction, instead of this way where you gotta distribute it, it's more confusing for me. On the first fraction, the x minus 1's cancel, so I get a 12, that's where that comes from. The second one, hallelujah, everything cancels, so I just bring down a 2. Oh my gosh, 12 plus 2, that's a first grade math problem. You see how I've made this nasty problem into 12 plus 2. Wow. I don't even need my calculator for that. On this side, the 4's cancel. So I have 7 times the quantity of x minus 1. Now, when I have this, I go right to this step. I distribute it when I write it in my next step. I don't care how many steps you take below the line, but when you end up solving this little puppy, you get x equals 3. Are you done? One more step. Go back up to your restrictions. And what's my restrictions? Oh, I forgot to do a restriction. The book forgot to do a restriction. What's my restriction here? Okay, you guys, help me out.
Click the bottom bar, mostly where it says mostly sunny.
Mostly sunny?
Click on. Oh,
Pop that up.
I didn't even touch the board that time. Mostly sunny. Okay, what are my restrictions for this problem?
X cannot be negative, X cannot be 1.
X can't be 1. I don't put anything with the 4, because the 4 doesn't have a variable. So the only thing that x cannot be is the binomial that has an x in it. I gotta put that equal to 0 and find out what the restriction is. So x cannot equal 0, so I should have this on my step, or x cannot equal 1.
Okay.
And now I go down to my solution here, and I get x is 3. Am I okay? Is
Yes.
that a good answer? Yeah. All right, with your group, tell me what the LCD is for each of these problems and what the restrictions are.
Just 24.
I would say 48.
48, that is a common denominator, it's not the least.
So
Then it must be 24.
Yeah. I always take the biggest number, 8, and do 8 times 2, that's 16. Will 6 go into 16? No. So that won't work. 8 times 3 is 24. Will 6 go into
Yes.
24? Will 4 go into 24? That's what I do. I always look at the largest number and then do multiples of it going up until I get one that it works. 48 does work, but you're just gonna have bigger numbers to play with when you solve. It won't be marked wrong. Okay, LCD is 24. Did y'all get that? Yes? You're not talking anymore. You used to be such a talky group. Krista made you quiet. All right. Do I have to do any work for number 2? Yes or no?
No,
Well, why not?
Say yes.
Yes,
Yes. What work do I have to do?
you'll need to multiply them,
X factor x squared.
Yep, I have to do
factor x
this.
squared,
Guys,
and x plus 1 on that one, and x
this
minus
guy
1 on that
here
one.
needs some work before I can do the LCD. It's 2 terms with a minus sign between it, so that's the twins. Remember we talked about the boy twin and the girl twin? X plus 1, x minus 1. When there's 2 terms, 9 times out of 10, it's 2 binomials. One's a plus, one's a minus. Take square root of the first term, that's x's. Take square root of the second term, that's that diagonal that's on your multiplication sheet.
You're factoring before you're multiplying them by the common denominator?
Before you get your LCD, you have to factor your denominators. Write that down. Before you can fill in that LCD, and I saw it on some of your extra credit, some of you handed in to me, you weren't doing that. You were writing it as x squared minus 1. That's gonna be points taken out. This needs to be factored. Now I'm ready to look for LCDs. The LCD, I always write the first denominator over here. So I get an x plus 1 and an x minus 1. Now I go to the second denominator. That's this guy right here. Any newbies that I haven't already written?
x minus 1.
I already have that. Any newbies? Does this have anything new that I haven't already written over there? No.
Sorry, when
X
we,
plus 1, I got an x plus 1. I don't need another one. I got it. It's there. So this guy is already over there. I don't need anything to get rid of this x plus 1. I'm going to get rid of
there's
it.
nothing to factor in number 1?
Now I go to x minus 1, this denominator. Is there anything in this x minus 1 that I haven't written over there? No, it's already over there. So we want to look at these and see that I've written them over on my LCD mark line. That's why I've always got to see your LCD, because you're always comparing what you're writing over there. Is there any new things here, here, or here that I haven't written over there? No, I've gotten them all. So my LCD is x plus 1, x minus 1. My restriction is that x cannot equal 1 or what?
Negative.
Negative 1. How did I get that? I put each of those binomials equal to 0 and solve. Now when I multiply this first fraction by the LCD, this whole thing's going to cancel out. I'm just going to get a 2x. When I multiply the second fraction here by that LCD, this is going to go away, but I'm going to have an extra x minus 1. This guy's got an x minus 1. When I multiply it by the LCD, I'm going to have an x plus 1. But make sure you know that this is a negative 1 times that parenthesis. Okay, last one. Solve the equation. What's my LCD?
X minus 2.
Angel?
X times x minus 2.
Yep. No work.
X times x.
This x is totally by itself. It's a monomial. And this is a binomial. Those are 2 different numbers when I finally know what x is. So the LCD is an x and then an x minus 2. My restriction is that x cannot equal 0 or a positive 2. Question?
So we're going to multiply 4 times x minus 2 and 2 times x? Or no?
4 times x minus 2, and then, yeah, your brain's way ahead of mine, equals 2x, yes. Yeah, when you multiply these two fractions by the LCD, you're gonna get rid of those denominators, and the left side is gonna have an x minus 2 on top, and the right side is just gonna have an x. Good question, thanks, Tim. That's today's lesson. It took me almost an hour to get through it. Part of it was review, part of it was watching for this restriction, if you have variables in the denominator. Now we're gonna get to the hard part about today's lesson. I'm not done. Go to the next slide. What's the next slide about?
Word problem.
Word problem. You're going, oh my gosh, are you really doing it? Now I need y'all to look up here, and you need to understand what I'm about to tell you. First type of problem is called work, W-O-R-K problems. Listen carefully, these are easy if you listen. If I call you and I say, I want you to come over to my house and weed my rocks. We're all weeding rocks if you have a house right now, right? And I call you to my house and I say, come over and weed. You say, okay, I got a job today, one whole job, do you agree? And you're gonna come to my house and weed all day. Called one whole job. Now, when I call you and ask you, do you wanna take this job? One of the questions I'm gonna ask you is, how long is it gonna take you to do this? You go, oh man, how many weeds you got? I go, I got a lot. You go, oh, it's about an 8-hour job. That one job, the total time will be 8 hours. Do you agree? Okay, now we have what we call your work rate. A work rate is how much of the job you get done per hour, or per minute, or per second. So if it takes me 8 hours to do the weeding in my yard, what's my work rate? 1 out of 8. I get 1/8 of the job done every hour. Does that make sense to you? Your work rate always has a 1 on top over your total time. So if you're building a house for me and you say it's going to take me 100 days to build your house, your work rate is 1 over 100. Every day you're going to get 1/100th of my house complete. If I call you to paint these walls, and it takes you 5 hours to paint the walls in this room, what's my work rate? 1 over 5. Every hour you will have 1/5 of the job done, and after 5 hours it'll be 5/5 or 1 whole job. Do you understand? Now, how many of you have ever had a job? Raise your hand. You guys haven't had a job over there? Babysitting job, something, come on, mowing, oh, you guys don't mow lawns here. I'm from Illinois. I made my son start his own lawn mowing business when he was 9. All right, so if you have a job, sometimes your employer will hire another employee to do your same job. So if you're working at McDonald's flipping burgers, there might be 2 chefs in there. Now, your boss can say to you, how long is it going to take you to do the job? And you say 5 hours. He goes to the other employer over here and he says, how long is it going to take you to do the job? And you say 10 hours to paint this room or whatever. Now the employee says, well, what happens if I hire both of you to do the same job and you work together? Is it going to take 5 hours?
No.
Is it going to take 10 hours? Only if he's watching this guy, right? But if you bring in more employees, don't you get the job done faster? Agree? Yeah. You know the Tom Sawyer story, you know, where he hires all of his friends to paint the fence? And he does that because it took him 10 hours to paint the fence, but if he hires all of his front row friends here to paint the fence, we can get it done in an hour. Well, what does that mean? Well, he could do 10 jobs in a day and get lots of profit. You see, your employer knows what I'm about to teach you. If you only hire 1 employee, or however long it takes them to do the job, that's how long it's gonna take them. But if I hire two of you, you're gonna get the job done faster. Well, what does that mean? Well, then I can do 2 jobs in a day instead of 1, and guess what? I'll make more profit for my company. Does that make sense? If I hire everybody in the room to pick my weeds in my yard, gosh, I'll have my yard done in about a half an hour instead of 8 hours. Well, I can go and do 16 yards in the day then, and if I'm the boss, I get a lot of what's called profit. Goes in my pocket. And I get to employ all 25 of you. Cool. You get money, I get money, life's grand. Today is about work. Work rate for a person is equal to 1 over the time to complete the whole job. Do you understand what that sentence means now? It's asking you, how long is it gonna take you to make me hamburgers tonight for dinner? If you say 20 minutes, your work rate is 1/20. Every minute you are doing 1/20 of cooking that burger. Okay, let's go through the story problem that we have here. Jerry can mow a lawn in 40 minutes. Now you're going, why are you talking about mowing a lawn? You can tell that this is my lesson from Illinois when I taught in Illinois for 36 years. They didn't know about rock yards and weeds. We have what's called
I mean, we
grass.
don't know about lawns.
They don't know about lawns, but you guys are gonna learn about lawns, because I didn't change the lesson. Should change it to rocks and weeding. All right, so Jerry can mow the lawn in 40 minutes. And good old Bill takes 60 minutes. Holy schmolies, Bill's a little slower. But me as a boss, I'm sitting there saying, well, if I have Jerry mow the lawn, it's gonna take him 40, Bill takes 60. But what happens if I have them do 1 lawn together? How long will it take them? Well, it's not gonna take them 40, and it's not gonna take them 60, because they got helpers. So one guy's doing the front of the lawn, somebody's doing the back of the lawn, so they're gonna get the job done faster, which means I get to get more jobs done that day and make more profit for my company. What do we do for work? If Jerry and Bill work together using 2 lawnmowers, how long is it gonna take them to mow that lawn? Oh, no. Well, your boss knows, because he's deciding whether he should hire a second person so that I get the job done fast, so I can get more jobs done during the day, and I can get more money in my pocket. This is every boss's math problem. Should I hire another employee? If any of you ever want to have your own business, you're going to be doing this problem to see if you should hire somebody else to help you do whatever your job is. Paint, weed, put down rocks, build houses, whatever.
Where's the amount
Make
of
a
lawn?
chart. The first column is your work rate of each person. Work rate. What's Jerry's work rate?
1 over
1
40.
over 40. How hard is this guy? You just put a 1 over their work rate. This isn't hard.
Alright,
What's good old Bill's work rate?
1 over 60.
1 over 60. How hard is that? Not hard. Now, what do we have over here? Work completed. How long does it take them if they work together?
You got 50 right there. It's 1 over 50.
1 over 60. Thank you. That's a mistake. I'll remember that. Okay. Time working together. Did it tell me how long they're gonna work together?
No.
No.
does it tell us how big the lawn is?
Wait a minute, no. We just know how long it takes them to mow that
To mow
lawn.
lawns.
Okay, so we don't know the time working together, so we're gonna call the time working together the letter T. So they're both working together T times. Do you agree? It's the same amount of time. so now what you do is you multiply these two boxes together equal the third box. Have we done that before? Yep, rate times time equals distance, this is
I
rate
see
times
this now.
time equals work completed. So, I go and I say work completed is T over 40, T over 60. All right, now we're going to do, and it says, if they work together, how long is it gonna take them to mow the lawn? Well, it's this amount of the job is completed by the first guy, this is the amount of job completed by the second guy, and when it's all done, it equals how many jobs? One. Always one. Now, if they say, how long is it gonna take them to do 2 jobs, you put it equal to 2. If they're gonna do 5 jobs that day, you put it equal to 5. See, so this is what the boss does to see how long it's gonna take them to complete 5 jobs, 2 jobs, or whatever. Since this is only one job, you put your equation, these 2 boxes, equal to 1 job. Now what do we have? We have an equation, and it's gotta be equal to something. It's equal to 1 whole job, always. The amount of work done by each person has to add up to 1. Now, what do I have to do? I have to get rid of those denominators. We don't play with equations with denominators. What number can go into both 40 and 60? I don't know, let's take 60.
120.
What's 60 times 2?
120,
120. Will 40 go into 120?
yes.
So my LCD is 120. So I'm gonna put a 120 here, a 120 here, and a 120 next to that 1. Everything has to be multiplied by 120. If I do it right, denominators go away, 3. Denominators go away, 2. I have 3t plus 2t equals 120. Ready to rock and roll? Done. Okay, here's my Tom Sawyer story that I used to give my kids when I taught high school. Takes John 4 hours to paint a fence. While his friend Tom, you know Tom Sawyer that tries to hire all of his friends to do his work? You guys know what I'm talking about?
Yeah,
Or am I
he actually
just old?
tricked him.
Okay, he actually tricked him, that's right. His friend Tom helps him, and the two work together to paint the fence, and they can do the whole job together in 3 hours. I have John's work rate. I don't have Tom's work rate, he's a little sly guy. But I have their total time working together. So again, notice I make a chart. What's John's work rate by himself? 1 over 4. How do I know that? Because I'm looking for how long it takes just you to do the job by yourself. Did they give you Tom's work rate? No, it says, how long is it gonna take Tom? That little sly guy, we don't know how long it's gonna take him. So he's 1 over X. I don't know how fast he can paint the fence by himself. He's always hired his slimy little friends to help him. Do I know the time that they work together?
3 hours.
3 hours, so I put a 3 and a 3. These are always gonna be the same, unless somebody comes an hour late to work or something, then you would say, oh, John has a class, he's not gonna work the same amount of time, you might have to subtract an hour or add an hour, that's the 151 class. You're gonna do these same problems in the next level class, just a little harder. Work completed is always multiplying the time times the numerator, put it over the denominator, 3 over x. Now, what am I gonna do? How long is it gonna take Tom to do the fence? How long is it gonna take Tom to do the front.
I'm too stuck on why he's on there.
3/4 plus 3/x equals always
Oh, I got it.
one whole job will be completed. If we take John's work rate plus Tom's work rate, they both work together, they're gonna finish that one whole job. Now, what's my LCD?
4x.
4x. So I put 4x, x can't equal 0, that's okay. Now I'm gonna multiply each thing by a 4x, a 4x, and a 4x. That's how you get the next equation. Easy peasy. Okay. Gonna go fast. Next one is about planes, trains, railroad. Do you guys know about these already? We've already done these, but now it's gonna be set up a little different. Watch. A boat can travel 16 miles against the current. In the same time, it travels 40 miles with the current. The current is 3 miles per hour. What is the rate of the boat in still waters? What?
Would it be 16/40?
Well, just, yes, we'll wait. Okay, we go down and we go against, right? With or against? Now, it says the current is 3 miles, so when you go down the stream, your boat speed gets the advantage of the current. Do you agree? Have you guys ever ridden a bike with the wind and against the wind, how different it is? So you put x plus 3 for the rate. Against the current is x minus 3, because you're fighting the current when you go upstream. Do you agree? They didn't tell me the time. It says in the same time, but we don't know what the time is. So I'm going to skip that. And notice I put the distance is 40 when we go with the stream. 16 is the distance against the stream. And to find the time, you divide these two. So we have 40 divided by x plus 3. And we have 16 divided by x minus 3. Now it says in the same time. When it says in the same time, what do you notice? You have to put these two time boxes equal to each other. This time box equals this time box. These two are equal to each other because it says in the same time. What do I have? Two fractions. What do I have to do? LCD. What's my LCD? X
Plus 3x minus 3.
plus 3, x minus 3, where x cannot equal 3 or negative 3. I'm going to multiply each side by that LCD. These cancel. These cancel. You get this equation. Solve, we get x is 7. What does 7 mean? That's your rate of your boat. Boat's going 7 miles per hour. Plane is going to be the same thing. Let me just show you what you should have in your chart. Let me show you your equation. It says the total time is 4. So your equation is going to have this time plus this time equals 4. It doesn't say in the same time, it says the total time is 4. So your equation is going to be equal to 4 because the story problem says it takes 4 hours for you to go with the wind and then come back home again. Again, you're gonna put your LCD as R plus 50, R minus 50. We wanna make sure that our answer is a negative 50 or positive 50, and I've shown you all the work. Apologize, one more. A certain number is added to the numerator and subtracted from the denominator of a fraction 5/8. You go, what? A certain number is added to the numerator and subtracted from the denominator. Did I do that? It's the same number. I just put x plus 5 plus x, and 8 minus x. And it says the new number equals the reciprocal of 5/8. You know what reciprocal means? Flip. If I was my high school teacher, I'd be doing a handstand right now. Reciprocal means upside down. So here's your math problem. Do I have fractions? Do I have fractions? Yeah. You have fractions, you need an LCD, and you need a restriction. What's my LCD? Well, I have an x minus 8 minus x, and I have a 5. I always put the number in front of my binomials, not behind it, but I won't mark it wrong if you do. Now you multiply each side by your LCD.
Oof.
And when you multiply each side by the LCD, these guys cancel. You get a 5 left on top times that binomial. Over here, the 5s cancel, and you get an 8 times that binomial. And when you solve, you get x equals 3. The number is 3. I'm done. I'm tired.
Can you go back one slide again? Just the quizzes.
Okay, you need to have on your desk quiz 16. That was a take-home quiz that I sent you. Your homework for 16, any makeup work that you might have done. Wednesday is the last day. I'll let you make up anything that you might have missed. Look at your grades. Kristen and I were in communication all the time. No, if you've done the take-home, you don't have to do that quiz that's on your desk. You can throw it away or shred it or leave it there. I don't care. Look at your grade sheet. If you missed any quiz, Alex and anybody else, you have till Wednesday to come in early before class, stay after class, and make up any of these quizzes. But after Wednesday, party's over for any makeup while I was absent. Zoe, is she coming to class?
I'm concerned.
Huh?
I'm a little concerned.
I am too, because she wasn't here last time I was here.
Or last.
And who's here, Kevin?
Yeah, Kevin is not yet.
Is he not coming to class either, or is he just today?
I'm not sure what's going on.
What's today's date? 3/25? Everybody was here, everybody was here. Is everybody here?